Okay guys, if you didn't get the warm-up, we're looking to see if the product of two functions with the period 2 pi is a period of 2 pi. Remember, anytime you're trying to disprove something, you only need one example. So I'm thinking of a product of two functions, and when I first think of that, I think of this product right here. 2 cosine theta, sine theta. That's one of the identities that we learned the other day, double angle identity. And that is equal to, let's see if I can get this over here. Oh, it's going to be another ugly day. Let's get rid of that. Sine of 2 theta. So, I have the product here of two functions with both have period of 2 pi. Well, what's the period of sine of 2 theta? Well, my b is 2. And I know that the period is 2 pi over b. So that's going to equal 2 pi over 2, which equals pi. So I have a product of two trig functions with a period of 2 pi with a period that is not 2 pi. So I have one example proving it not true. It must not be true. Okay, that's it. Okay, so what we're going to do today is cover the law of sines. You're going to use the law of sines to solve AAS and ASA triangles. Well, what's an AAS and an ASA triangle? Well, angle side would be where you have an angle, you have another angle, and you know one of the sides. Okay? So angle, side, not the side between them. ASA would be when you know two angles and the side between them. Okay? We're going to solve the ambiguous case, which is the SSA triangle, never the ASS triangle, and we're going to solve angle and distance problems. Your language objective is to state the law of sine in words. There's a cartoon for you. Okay, the law of sines. Now, up to this point, we've only been solving right triangles, and we've been using simple trig and the Pythagorean theorem. But simple trig and the Pythagorean theorem doesn't work on this triangle. Why is that? Well, the simple answer is it's not a right triangle. So we can still solve for sides and angles of triangles even if they're not right triangles. And one of the ways that we do this is with the law of sines. So if you were in my class last year, you might remember the law of sines. It's the sine of A over A equals the sine of B over B, which equals the sine of C over C. So I have three ratios. If I set them equal to each other, I can solve for any unknowns that I have. Okay, so if all triangles were right triangles, we could end the chapter right now. But unfortunately, there are triangles that exist that are not right triangles. So in that case, we have to have a method to solve them. So here's our first triangle. Let's solve the triangle by finding the missing pieces. Well, what do I know about this triangle? It looks like I have two angles and a side. So this triangle is going to be an AAS triangle. Let's see if I can get my cursor up here. No, now it's up too high. An AAS triangle. An AAS triangle is one that I can use a law of sines to solve. So, what do I need to know? The first thing I need to know is over here, I need to know angle C. And that's pretty easy because the three sides, or the three angles of a triangle, just add to 180. So all I need to do is take 180 and subtract the sum of the other two sides. I'm going to get 180, 141, and I'm going to get 39 degrees. Okay, so I know that angle C is 39 degrees. So now I can use the law of sines to just solve for the other sides. So let's start with side A. The sine of A over the length of A, which is right here, equals the sine of 29, which is B, the sine of B, over the length of B. So now I just need to substitute in. Sine of 112 over A equals sine of 29 degrees over 22. So that means 22 sine of 112 equals a sine 29. And a is going to equal 22 sine of 112 all over sine of 29. Now when you're solving these, I would recommend don't, put the signs in and do it piece by piece. Just wait till the end, you do one big calculation, you get your answer. Okay? So for A, I ended up getting 42.1 about. If we round to one decimal place, that should be good. So now I just have to do the same thing to find the length of side C. So I get the sine of C over C equals, I can either use A or B here, it doesn't matter. I'll just use B since I already have those values. So the sine of 39 degrees over C equals the sine of 29 degrees over 22. So working this out, I'm going to get C equals 22 sine of 39 over sine of 29. So C is going to equal about 28.6. So now I have my length of side C, the length of side A, and I have the angle C all solved. I'm done. So that's it. You're just looking for missing lengths and missing sides, and you're using the law of sines to do it. So why don't you give a go at the next problem. I'm going to do it up here while you're working it at your desks. I got 5.05 for C, and I'm going to do that same process again for B, for A, I mean. And if you can't read that, it's 4.53. So A is 4.53. C is 5.05. And angle C is 75. So there you have it. And by the way, this was an AAS triangle. So there you go. So what type of triangle is this? Let's find the missing pieces. Well, I have angle, the side included between them, and angle. So this is an ASA triangle. we can solve ASA triangles using law of sines. So let's do it. I know the measure of angle C is 28 degrees. Okay, let's use the law of sines. So the sine of 28 degrees over 46 is going to equal the sine of 20 degrees over B. So B is going to equal 46 sine 20 all over sine of 28. So B is going to equal 33.5. Okay, so the last angle we need to solve for is angle A. So the sine of angle A, which is 132, over the length of A equals, I can just use sine of 28 over 46 again. So I know that A is going to equal 46 sine of 132 all divided by sine of 28. A is going to equal about 72.8. So there you have it. So it's a pretty simple process. You're just plugging in for AAS triangles, ASA triangles. Okay? So here's an example for you to do. You can just do it at your desk. I'll put the answer up here as soon as I do it. Okay? So 17.8, 17.9. A is 30.6, and angle B, of course, is 45 degrees. There you go. Now, the last one, which is called the ambiguous case, is the SSA triangle. Suppose we're given two sides of a triangle and one angle which is not included to make a triangle. How many triangles could we make? Well, let's look at our different options. Okay, so here's my triangle. I have my angle of 63 degrees. I know this side over here is 25 degrees, and I've been given this side a length of 18. Okay, so I'm trying to decide how many triangles I can make. Well, in order for us to make a triangle, my height has to be at least 18. So let's check and see if my height is indeed 18. Well, how would I find the height of this? It's a right triangle, right? So what do I know? I know the angle. I know the hypotenuse. What I need to find is the height. So I need something that relates the opposite side and the hypotenuse. It looks like I'm going to use the sine function. So sine of theta is the opposite side over the hypotenuse. Okay? So in this case, sine of 63 degrees equals my height, h, divided by 25. So 25 sine of 63 degrees equals h. Okay, let's put it in our calculators and see what we get. Okay, after putting it in my calculator, I see that my height is 22.3. So if I try to take this side here, which is 18, and stick it in here, it's going to be short. It's never going to reach both sides of my triangle. So I know that because my A value is less than my height, there are no solutions or no triangles. Okay? So that's what happens in the case where you're given an angle, two sides. The second side is not as long as the height. So you're going to check that length against the height. Okay, let's look at another option. Okay, let's look at this situation. In this situation, I have my angle that I've been given here, 105 degrees. The side next to my angle is 55. And the side that I'm going to see if it fits or not is 73. Now look at the relationship here between A and B. A is greater than B. So that means if I stick it in here, there's only one way it could possibly fit. So when you have your opposite side, A, greater than the side next to your angle, you're only going to have one solution, always. Okay? Let's look at another option. Okay, what's going on here? I have an angle of 72.2. The side next to my angle is 22, and I've been given a side of 21. So first of all, let's see if it's going to fit in my triangle by checking my height here, h. So let's find h. So I get the sine of 72.2 equals h over 22. 22 sine of 72.2 is going to equal h. So that means my h value is going to equal 20.9. Now look at 20.9 is less than this side, so that means it's going to fit in there. So let's put it in. Okay, so this is one way I could put my second side into the triangle, but think about it, it's not the only way, is it? I could also draw a triangle like this. Watch what happens when I put it on the other side of my altitude. It makes a triangle there as well. So in this case, I am going to have two solutions. I have the case over here where my 21 is on the right side of the altitude. I have the case over here when the 22 the side is on the left side of my altitude. So whenever we're working with SSA triangles, we could have the option of having no solutions, one solution, and two solutions. So let's look at some examples and see if we can determine which is which. Oh, one thing I forgot to say here. Notice here that A is greater than H, but side A is less than B. So whenever you have a second side that's greater than the height, but less than the first side, and A is an acute angle, you're going to have two solutions. So let's take a look at some examples. So first, let's solve the problem when I have my side on the right side of the altitude. So just a simple law of sines problem. I have sine of A over A equals sine of B over B. So I get the sine 72.2 over 21 equals the sine of B over 22. So I'm going to get 22 sine of 72.2 over 21 equals the sine of B. Now notice, the answer I'm getting here is the sine of B. I'm not looking for the sine of B, I'm looking for B. So how am I going to get that B out? Well, I'm going to have to use the inverse function. If I take the inverse sine of the sine of B, what's going to be released is my B. Because anytime I have an inverse and a function composed together, you get out what you put in. And in this case, I put in a B, so that's what I'm going to get out. So I'm just going to put this whole monster in my calculator. The inverse sine of 22 sine 72.2 all over 21. I just leave my calculations to the end because then A, you have to make less of them, and B, you're not introducing any error by rounding off. So let's go ahead and put that monster into our calculator and see what we get. So I'm going to end up with B being 85.9. And as you can see, I put the answers down here. You can check them there. So now that we know B, we're just going to go back and solve for C. So I have the sine of C over C equals the sine of A over A. Now notice here, I forgot to go back and solve for C. So I know that B is 85.9. So C, the measure of angle C, is going to equal 180 minus 72.2 plus 85.9. Those are both degrees. So I'm going to get the measure of angle C is 21.9 degrees. Okay, so now I can take my 21.9, bring it up here, and solve for side C. So the sine of 21.9 degrees over side C equals the sine of 72.2 over 21. Okay, so I'm going to get C equals 21 sine 21.9 degrees over sine of 72.2. And if I put that in my calculator, I'm going to end up with C equals 8.2. Okay? So that's one of the triangles we can solve for. That's if we use our second side on the right side of the altitude. But what if we put it on the left side of the altitude? Well, we're going to get a different triangle. Some of the things will be same about it, but some will be different. Let's take a look at that. Okay, here you can see I have my altitude on the left side of, okay? So one thing we need to note is that when I had it drawn over here, what was this angle right here? Angle B was 85.9. Now notice that this side of this triangle and this side of this triangle are the same length. They're both 21. That makes this an isosceles triangle, which means this angle right here is 85.9. So I won't want to do any extra work. So I'm going to take this value from the previous one, and I know if this is 85.9 and I'm making a straight angle, then this side here, the new angle B, must be 180 degrees minus 85.9. So when I subtract that out, I am going to get a new value, and it's going to be 94.1. So now I'm going to solve my second triangle using this value of 94.1. So first of all, let's solve for, how about angle, let's see, we know angle A, we know side A, we know angle B, we know side B, we don't know angle C. So angle C is just going to be 180 minus the sum of 94.1 plus 72.2. When I solve that out, I'm going to get C equals 13.7 degrees. Okay? So now I'll use the law of sines, and you can solve for that side of C. So I get sine of C over C equals, I can use either A or B here. I'll just use B since it's handy. So I get sine of 13.7 over side of C equals the sine of 94.1 over the length of C, which is 22. So I go ahead and solve that, and I get C equals 5.2. Okay, so now I've solved for C. Up here I solved for angle C, and over here is where I solved for angle B using the measurement that I knew from my first triangle. So it's a little bit less work than the first triangle. Use that information to give you a hand. Okay? Okay, what we're going to do next is just look at some problems and see how many solutions there are. So, here we go. How many solutions? I don't want you to solve these, just tell me how many solutions, and then we'll talk about it when you're done. Okay, when I'm doing these problems, I try to always draw them the same way. If I always draw them the same way with my angle on my left and the side on my left and then the second side on my right, I never mess up. I'm going to draw what I have here. And I try to approximate the size as much as I can. I know this is angle A. It's 36 degrees. Now if this is side B at 7, that means this must be angle B. This is angle C up here, and this side is 2. It's not a very good picture. What I need to do is check my height and see if the height here is smaller than 2. Okay? So I get the sine of 36 equals h over 7. 7 sine of 36 equals h. And I'm going to get h of about 4.1. So what that's telling me is that my altitude here is 4.1, but the side I was given is only 2. Obviously it's not going to fit. So this one, we would have 0 solutions. Okey-doke. Okay, let's look at our second triangle. Again, even though this is a side C, I like to draw it in the same position, because if I don't, it screws me up. So let's draw this one. 36 degrees. This is going to be angle C. Side C over here is 16. And side A over here is 17. So now I know I can label this side B, or angle B. This is going to be angle A over here. So I'm comparing A and B. I see that C is less than A. Let's compare now C to my height. Okay? So in this case, I get sine of 36 equals h over 17. So 17 sine of 36. And if I calculate that out, I'm going to get an h of about 10.0. So now in this case, C is greater than my height, but C is less than my initial side. So that means I could possibly draw a line in right here for C and make it 16. So in this case, I have H is less than C, which is less than A. Okay? So in this case, I am going to have 2 solutions. Okay, let's look at our last one. Again, I'm going to draw the picture just the same. My angle over here, 30 degrees. That's my C. This side's A equals 18. So that should be a little bit longer maybe. And this side over here is going to be 9. So I'm just going to drop this side down. C equals 9. And that would make this A over here, and this is B up here. Okay? Once again, let's drop my altitude, find out how big my height is. So I get sine of 30 degrees equals h over 18. 18 sine of 30 degrees equals h. Those of you that are really quick, the sine of 30 degrees, as you know, is 1/2. So 18 times 1/2 equals h. 9 equals h. So what does that tell me? This is 9. This is 9. If the height equals the other side, well, this must be the other side. So this is just going to be a right triangle. Okay? Right triangle, there's only going to be one solution. Okay? So you kind of get an idea of how those work out. Okay, let's go and practice on a problem. So find all solutions to this. I'm going to give you a clue. It's probably going to have 2 solutions. So go ahead and work it out. I'll work it out up here. Make sure you draw your picture always the same. So there's your first triangle solved, 12.2, 72.7 degrees, and let's see, what's the third thing? 43.3. Okay, so now we need to solve the second triangle. Okay, let's draw our second triangle. This is 64. Side is 17. Side, this is going to kind of open up. I didn't mean to draw it kind of right like that. It's actually over a little bit. But I know that this angle right here is 72.7. This is 16. So I know that this angle here is going to be 180 minus 72.7 degrees, which is going to give me 107.3. Okay, so this angle here is going to be 107.3. I know this angle here is 64. I can subtract the two angles from 180 to get the third angle. So I'm going to get 180 degrees minus 64 degrees plus 107.3 degrees. It's going to equal 8.7. Now remember, this 72.7 was from the other problem. This made an isosceles triangle right here, which is why we knew that. Okay, so this right here is 8.7. So I know two sides. I know 3 angles. I just have one thing to solve for, and that is going to be the length of this side right here. And that's A, this is B, and that's C. So the sine of C over length of C equals the sine of B over the length of B. So the sine of C, oops, C we said was 8.7, sine of 8.7 over C equals the sine 107.3 degrees over 17. So C is going to equal 17 sine 8.7 divided by the sine of 107.3. And I'm going to get a C of about 2.7. Okay, so there you have it. Okay, let's do some real world problems here. I have a baseball fan sitting directly behind home plate in the last row of the upper deck of Comiskey Park in Chicago. The angle of depression to home plate is 29 degrees 54 minutes. The angle of depression to the pitcher's mound is 24 degrees 12 minutes. In Major League Baseball, the distance between home plate and the pitcher's mound is 60.5 feet. How far is the fan from home plate? Well, obviously this is going to require a picture. So here you have it, your picture. Okay, so where is our man in the stands? He's up here. Here's home plate. You can see the angle of depression to home plate is 29.54. You can see the angle here to the pitcher's mound is 24.12. Notice, these two lines are parallel. So the angle of depression here is the same as the angle of elevation here. Now, we need to find theta here. In order to find theta there, we need to subtract this smaller angle from this bigger angle here to find the difference. So let's go ahead and do that. So I'm going to get 29 degrees, 54 minutes, minus 24 degrees, 12 minutes. When I do that, I am going to end up with 5 degrees, 42 minutes. Now, working in degrees and minutes is not so handy for me, so I'm going to put this in my calculator under degrees, minutes, seconds, and I'm going to switch it into decimals, and I'm going to end up with 5.7 degrees. Okay, so theta over here is 5.7. So what do I know here now? I know an angle, I know a non-included side, I have an AAS triangle. Okay, again, we have degrees and minutes here. Let's switch that into decimal, and I'm going to end up with 24.2 degrees. Okay, so this will be an easy problem now that we have everything figured out. All we need to do is use law of sines since it's an AAS. So let's find some space on here and see if we can do that. So I'm going to get sine of 5.7 over 60.5. Now what am I looking for? I'm looking for D, so the angle opposite I know is 24.2. So I can get that equal to sine 24.2 degrees over D. So D is going to equal 60.5 sine of 24.2 all over sine of 5.7. I put that in my calculator, and I'm going to end up with a D about 249.7 feet. So even though it was a complicated looking problem in the beginning, once we drew a picture, determined what angles we knew, it was easily solved using law of sines. Okay? Here's one for you guys to solve. See how you do. I'll solve it up here and give you the answer. You solve it at your desks. Okay, so far today we've been solving ASA triangles, we've been solving AAS triangles, and we've been solving SSA triangles. Well, what about SSS and SAS? Well, those triangles don't give us enough information to use the law of sines. So what we're going to be doing is doing law of cosines next time I see you. Sound good? Okay, so what I'd like you to do now is write down the law of sines and state to your table partner what is the law of sine in words. Okay? Here's your homework for next time. Have a good day. I will see you on Tuesday. Goodbye.